begin our lesson. So guys, the topic of the lesson today is to carry on with equations. And when we talk about equations in maths, we often talk about solving them. And in the last lesson, we did quite a lot of work with that. But some of you were asking me a lot about this thing about doing the same thing on both sides. And so I just want to illustrate a few of the ideas before we properly get started that I used in the last lesson. So whenever we solve an equation, you'll often see me saying you have to do the same thing to both sides. And I just want to show you a little bit more about what that is all about. So if I say to you, 4 is equal to 2 plus 2, in some senses, that's an equation. It's got an equal sign, 2 terms. Now, if I go ahead and add 2 to both sides, okay, if I add 2 to both sides, well, let's say I add 3. If I go plus 3 on this side and plus 3 on this side, you will notice that this equation is still true. When we started, it was 4 equals 4. Now it's just 7 equals 7. So when we are solving an equation and I say do things to both sides, why I'm saying that is if you do the same thing to both sides, it keeps the equation equal. However, if I went along and only added 3 to one side, well, then what would happen is I would say 7 equals 4. And that's not true. So that's why I spend so much time saying whenever you do one thing to the one side, you must do it to the other side as well. And you'll see me going on and on about this. Now, this doesn't just work for addition, it also works for other things. So say, for example, we want to times this side by 3 of the equation. So I times it by 3. Now, if I just stop there, then what I'm saying is that 12 is equal to 4, which is not true. However, if I also times the right-hand side by 3, then what happens? Now, there's something else we're going to deal with today, is that if I want to times the whole side by something, I often will have to put a bracket around it. So what happens here? Well, on this side, if I times both sides by 3, I get 12. And over here, if I distribute my bracket, well, what's 3 times 2? It's going to be 6. And so we get that. So there's one important idea I want to get across. If you do the same thing to both sides, you preserve the equals sign. If you don't do the same thing to both sides, you break it. Give me a thumbs up if you understand that. Give me a thumbs down if you don't understand that. I want to see in the chat how my people are doing. Okay. Now, this is the foundation of solving equations. What you do to the one side, you do to the other. And if you do that, you do not change the equation. Okay. Now, the second thing is we use inverse operations to isolate the variable. So let me give you an example. If I say x plus 4 is equal to 10, in the last lesson, we spent a lot of time asking ourselves, okay, when we solve an equation, we solve an equation by trying to isolate the variable. We need to figure out what x is. Now, a lot of you will be able to see what the answer for x is right now. Put that answer in the chat. We call this solving an equation by inspection. What is the answer to this equation? Okay, it's 6. Now, if we were going to use the method that I'm suggesting for solving equations, what we do is to isolate the x. We look at whatever is near the x, and we use the inverse operation. Now, what would be the inverse operation of plus 4? What's the opposite of plusing 4? Okay, it's minusing 4. Now, what some students get a little bit confused about is they don't think about doing this minus 4. And what they say is they just go to the next step. And it's not wrong to do that. But basically, what I want to show you is when you take away 4 from both sides here, what happens is you knock out the thing on this side And what it looks like is that you just have a -4 appear on the other side. And what's really happening is that the bit on this side is being knocked out by the inverse operation. And so we basically just rub it out. And so a lot of students basically just say, if I've got a +4 on one side and I move it across, it becomes a -4. It's not wrong, but I prefer for you to think about this as saying, look, I'm taking away 4 from both sides. And so my answer will be 6. Okay. So we're going to use that. Now, when we get to a question, let's say I've done that one already. Whenever we solve an equation, we use the inverse operation and we always do it to both sides. Now, in this case, if I say to you, what's the answer to this equation? In the chat, give me the answer to this equation just by looking at it. Okay, now everyone can see the answer is 5. But let's use our method. Our method says we need to isolate the variable x. And what is the relationship between 3 and x? So what is the relationship at the moment between 3 and x? I want to see in the chat. It's multiplication. And so the opposite operation to multiplication is division. And so what I'm going to do is I'm going to divide by 3. But now I don't stop there, because if I stop there, I've unbalanced the whole world. I break my equality. So now I divide both sides by 3. And the effect of dividing by 3 is that 3 over 3 is 1. And so we get 1x. But fortunately, on the other side, I get 15 divided by 3, and that gives me 5, which is the answer you all knew at the very beginning. Okay, so let's try this out on a harder question. What if I said to you, I want you to solve this question? I would love somebody to put their hand up and tell me what they think the first step would be, or to put in the chat. I would love to hear what you think. Explain to me using this method what you would do.
Ayanda wants to help us.
Ayanda, can you hear us?
Hello. Yes, sir.
Okay. Tell me what you think the first step should be.
So to do your inverse operation, so like say 11 minus 1 will give me 10. And
okay,
then...
let's stop there for a second. You're perfect. So you're saying the +1 needs to be taken care of, and you are going to take away 1 from both sides. Understanding you correctly?
So only on the other side. So 2x will just be equals to 11 minus 1.
Yes, that is true. But can you see how you're right? So you're saying you're going to get to this step. But what I want to show you is, can you see what you're really doing is you're just taking away 1 from both sides? Does that make sense?
Yes, sir.
So what's happening is when you take away 1 from both sides, it has the effect of saying, look, it just looks like this. But really what's happened is you've taken away 1 from both sides.
Yes, sir.
Can you help me with this next step? What would you do here?
So after I've gotten divided by 2, because I need to get the x by itself, and I need to divide on both sides.
Perfect. Perfect.
Because they are multiplied.
So what's your final answer going to be?
It'll be 5.
Absolutely perfect.
Oh, well done, Ayanda. My people are on fire today. Well done.
Can you hear me okay, Yolanda, or am I lagging, or who's
I think it was Ayanda's network. I couldn't hear Ayanda perfectly well, but not really.
Before we get into the proper questions for today, or the things, I want to do 2 more types of questions. I want to ask students, what happens when we get a question like this? Now, this is going back to the previous unit. If I say to you, you have to solve this equation, in the chat or in the, if you raise your hand, I want to know, what do you think the first step would be in an equation like this? So pop it in the chat, or Thomas, I'm going to come to you. What do you think the first step would be here?
Thomas, remember to press that button that you see on your screen, okay? So you can talk to us. So you have to, it's asking you on your screen right now.
I want to know, what do you think the first step is here in order to start solving this equation? So I'm going to come to Onati because Thomas seems to, or Thomas, are you with us? Okay, I'm going to come to Onati. Maybe you can help me.
Sir, can you hear me?
Loud and clear.
Okay, I think you should plus the variables first.
So we say we collect the like terms. So we have 1x and 2x, and what do you get then?
3x.
Exactly. So we're using another technique where when we have like terms, which we just learned about in the previous module, we can add like terms together. Do you remember that from the last module on our team?
Yeah.
So now tell me, what's the next step after this?
And then we move the 3 to the other side to divide it. We divide both sides as well.
Okay, I love it. I know I'm being such a pest with this, but I know that students need to understand that I'm always doing the same thing to both sides. What it looks like is that I'm just moving it across, but really underneath the hood, the magic that's happening is we divide both sides by 3. And what's your answer here?
For the 9 divided by 3, the answer is 3.
Perfect.
Well done, Unati. Well done.
Well done. Okay. We have one more example, and then I'm going to let you guys loose on practice questions. What happens? So you guys are doing incredibly well. And so I'm just going to kind of run with this idea because I know we're going to practice this the whole lesson today. And so I just want to make sure I've covered all the different types of examples. If I say to you, here is an equation, and I want you to solve for x. There are actually 2 ways we can do this, and I'm going to show you both. But I would love for students in the class to just either put in the chat or give me some feedback about how they would approach this. And I'm going to come to Kamogelo, if Kamogelo is willing to share with us. Otherwise, there we go. Kamogelo, what do you think?
So, sir, if you see a number, if you see a number is next to a bracket, so you automatically think, or you automatically know that bracket means times. So what you're gonna do, so 2 times x equals to x.
So 2 times x is 2x, okay, and then
you're gonna say 2 times 3 equals to 6.
Perfect. And you know what? That looks a lot to me like the previous question. So you've actually made the difficult stuff easy. So thank you so much. Could you help us with the next step? What would your next step be?
So what you're gonna do is you're gonna do what you're gonna say is x equals to.
But think about what we've been learning about. We want to get the x by itself. What is the inverse operation of plus 6? Okay, we'll just hold on for a second. I think we might have, Kamogelo, have we still got you? I think let's go to Tando. Maybe Tando can help us. And then, guys, we're going to get going, I promise.
Well done, Kamogelo.
Yes, hi, Tando.
So, sir, what part am I doing?
So you're telling me what to do from 2x plus 6 equals 7.
Okay, so what you do is you're gonna say 2x plus 6 minus 6 on the right hand side, and then 7 minus 6 on the left hand side.
Okay. So basically, you're saying take away 6 on both sides. Now, what I'm going to do is I'm going to say, you know what? I'm starting to write. I take away 6 on this side, and it knocks this out. Actually, and then on the other side, I take away 6, and that still has to be there. So really, you get that effect. All I've done is I've left out a step. Does everybody understand that? So I've taken away 6 on the left-hand side, and all I'm left with is 2x. I take away 6 on this side, and I got that. Tando, what did you get for that then?
Then I got 2x as the answer because 6 minus 6. And then for 7 minus 6, I got 1.
Perfect. And can you help us to do the last step here?
And then the last thing you do is you divide on both sides.
Divide both sides by what?
By 2.
Ah, because you know it's the opposite of timesing by 2.
Yes, sir.
And what's your answer then?
X equals minus 1.
Okay, it's not minus 1. So be careful. I'm going to cross out these 2 2's.
Oh, sir. It's
What's it
actually a half.
A half.
Yeah.
Well
Perfect.
done, Tander. Well done. Oh,
Okay.
that was good.
So guys, I know I'm being that irritating teacher who's like keeps coming back to the same thing, but the golden rule is we have certain strategies that we are going to use today. And I've given you an example of those strategies, but now we need to practice them. And so even if you're feeling a bit unsure, just keep thinking, what were some of the ideas I saw in the first bit of the lesson? And it's time for us to take our strategies on the road here. So let us go to a previous exam question. And I'm going to ask you guys to try and do for me. Let me blow this up. I'm going to ask you to try and solve that one and try and solve that one. And so we're going to leave 8.3 for now. But I want you to try and do the 2 ones in yellow using the techniques that we spoke about now. And then if any students would like to ask questions, we would love to have a conversation while students are working on this. Okay, Amakle, let's go to you.
So I wanted to ask a question, but I understand it now.
Okay, perfect.
Thank
So
you.
pleasure. I know there will be students who want to ask more questions because they may think, oh, this is a bit different to how I do it in class, or they might just be unsure. And so just to remind you, we have Yolanda who is taking care of the chat. Her fingers are on fire there. She's moving so quickly. And then there's me who would love to help you if I can. So don't be afraid to put your hand up. Okay. Sibosiso, let's go to you. I'm asking you to unmute, and then if you just unmute yourself, you should be able to ask a question. Sibosiso, there's a block at the bottom, but you just click and it says, I'd like to unmute, and then it lets you. There we go. Sibosiso, how can I assist you?
Sir?
Yeah.
Sir?
Yes, I can hear you loud and clear. Welcome.
Sir?
Yes.
Sir? Please,
Yeah.
I don't understand the question 8.1.
Okay.
Sir?
Yeah. So let me try and explain it, and then we'll have a conversation. In 8.1, it's saying here is an equation, and it's 6a plus 4 is 22. And you have to solve the equation for the unknown variable. In this case, we're trying to get to the point where we say a is equal to something. And that something, if we get it correct, will make this equation true. So that's the question. Now, what I'm going to encourage you to do is use a strategy that you've learned earlier in the lesson, which says, in order to solve this equation, I need to isolate the variable. And in order to get it by itself, I need to spend some time thinking about this plus 4. And so I want to ask you, Sibosiso, what is the opposite of plus 4? Can you hear me?
Sir,
Yeah.
hello.
Yeah.
Sir. Hello.
So we can have a talk, because I think that you can't hear us and we can hear you.
Okay. So basically, let's go to someone else's question. Tandy.
Hello.
Hi.
Oh, my question 8.2. I don't understand how that works out.
So what 8.2 is saying is it's b divided by 4 equals 5. I want to ask you, what is the opposite of dividing by 4?
Multiply.
Okay, but now if I multiply one side by 4, am I allowed to just stop at that point? Or have I broken
No.
something? So what do I need to do?
What you do at the top, you do at the bottom.
Not quite. That would be for fractions. Think back to the beginning of the lesson. What do we always have to do? When I gave that example, when I said 4 equals 2 plus 2. Do you remember when I said you always do the same thing to both sides?
Oh, yes. Sir.
So you multiply both sides by 4. That's where I'm going to be with for now. Okay, when you got your answers, guys, for the questions, put them in the chat. I'm going to mark them now, and then we're going to do some more. And if you're feeling unsure, don't worry. We're going to keep practicing. So Neo, what's your question?
Afternoon, sir.
Hello.
I have a problem with 8.3.
Okay, I haven't got to 8.3 yet, so I will come back to that, but for now, we're just going to do 8.1. Okay, let me have a go at 8.1. So what I'm going to do with 8.1 is all I'm going to do is the thing in life that is giving me a headache is this +4. So you know what we do with a headache? We take a grandpa headache powder, or maybe, I don't know, maybe you don't. But anyway, that's my analogy. So I take away 4 from both sides. And what I'm left with is I now have these guys knock each other out. Thank goodness. Goodbye. Now I get 6a equals 22 minus 4. And what is that? It's 18. And now I go, oh my goodness, I've got a new headache. But I've got a new tool to help me. So I've got 6a equals 18. 6 times a is what that means. Now, what is the opposite of timesing by 6? It's going to be dividing by 6. But my teacher told me if I do one thing to one side of the equation, I have to also do it to the other side. Okay, now what I'm going to do here is I'm going to say 6 over 6 is the same as 1. And so they cancel each other out. So I'm left with just the a on the left-hand side. On the right-hand side, I've got 18 over 6, which is going to give me my final answer of 3. Now, if I've been a good teacher, and hopefully I am, this, when I put it back into the original equation, it should make the statement true. If it doesn't do that, guys, then I haven't solved for the correct answer. So let me see what happens. I'm going to go back to my original. If I go 6 times 3, I get 18. And if I add 4 to 18, I get 22. So the good news is, I'm telling you the truth. The answer really is A is 3. So we need to just practice this some more, but I want to emphasize what I did. I found my first problem, which was the +4, and I dealt with it. I found my second problem, which was multiplying by, which was basically the 6, and I dealt with it. And in the end, I left you with a very all by itself, or what we call isolated variable, which was the answer. Now, in the second question, what I have to do here is all I have to do is multiply both sides by 4. The reason I chose to multiply by 4 is, you guessed it, it's the opposite of dividing by 4. And dividing by 4 is what the question started with. So these 4s cancel out, and my final answer will be B is equal to 20. So all I think we need, I'm not going to do 8.3 yet. We'll come back to that. I want to practice another one like this. Okay, so let's do another one like this. In fact, let's do these 3 questions. And after we've done these 3, we're going to take a break. So to my grade 8 students, all I want to say is that there are 2 golden rules in equations. You look to, basically, you use the opposite operation to whatever is giving you a headache. And then you always do it to the same thing to both sides. Over to you. I want you to try and solve these 3 equations. And while you are working on that, I will take questions from you either on the in the chat or put your hand up and I will help you. But I feel like I've given you enough clues to get going with this. But yeah, please ask questions if you need a bit of help.
Let's do this, guys. You guys are doing really well. Just remember that you're doing well. So we go step by step. I think you panic because you see 8.3. You're like, oh, I don't understand. But you already got 8.1. So you give your marks. Maybe Teacher Peter, can you tell us how many marks do we get for 8.1?
Okay, we're going to go back. 8.1 isn't hard, but we just need to build our muscles first. So
yes.
This 8.1 was 2 marks. 8.3 was the tougher one. Yeah.
Okay, so it's 2 marks on our back, guys. Then we celebrate because it's 2 marks. Then we move to
here we go.
2. So you see, don't panic. As long as you go slow and slow at the end of this lesson, you'll understand 100% of this stuff. So let's try 10.1. There we go, 10.2 and 10.3. Let's do it, guys. Yes, you know, I believe in you. Let's.
It's all about having a game plan. I sound like a sporting coach, don't I? But you just have to learn the techniques that we have here. And then we just keep going with those techniques and applying them in more and more difficult matches. I do like my sports analogies, don't I? But yeah. Ngwazi, are you sorted? Sweet. Awesome. Okay. Let's do this. Let's do this. Okay, Sivanati's got an answer coming in. There we go. Okay, quite a few answers are coming in. Let's keep practicing, guys. Keep going.
Remember that now is the time that when you feel confused or anything, you can raise your hand while others are busy doing 10.2, 10.3.
Yeah.
Nice.
Exactly that. Now is a great time. If you want to ask a question, it's a great time to ask while everyone is working hard.
Hi, Tandeka.
Yep, go ahead.
So I was just asking if I could answer 10.1.
Oh, sorry, I beat you to it. But could you maybe help me with 10.2?
Okay. So I got 32 for 10.2.
Okay.
So I found out what do you need. Let me just rephrase it. So I found out that 5. First I said 5 plus 27 equals 32. So then I found out that 32 is x.
Yeah. So basically you added 5 to both sides. Some people would say you moved the 5 across to the other side, but we know essentially it's the same thing. And you got the answer of 32. Did I hear correct?
Yes. Yes, sir.
I agree with you. X is definitely 32. Yeah. Would anybody else like to help me with 10?
Well done, Tandeka.
Well done, Tandeka. Yeah, very nice. Anybody like to help me with 10.3 before we take our little break?
Hi, Tatenda.
Let's go to Scarlett. Scarlett, can you help us out with 10.3? I'm trying to unmute if you can unmute on your side. Yeah.
Hello, sir. Can you hear me?
Hello. Yeah, loud and clear.
Okay. Sir, I'm not finished with the sum, but I would like to try. That's fine.
Okay, go ahead. Yeah.
Okay. So, what I did was, I said 25 minus 5, which gave me 20.
Okay. I just want to quickly check.
I mean, plus 5, sorry, sir.
Okay, fantastic. Can you just tell me, why did you choose plus 5? What was your thinking behind plus 5?
Because
sorry, I'm being difficult, but it's so important because it's for everyone to understand. You chose plus 5 for a reason. And so I'm interested in that.
yeah, so because it's the inverse of a,
Yes.
yeah.
It's the opposite of this annoying minus 5.
Yeah.
Right? And so you had a headache, and now you've cleared your headache. So what do you do with your plus 5? What did you say you did?
So I plus 5 and got me to 30.
Perfect. Okay, so I'm gonna even miss that step. Basically, you added 5 on the left, it knocked out the minus 5, and you added 5 on the right, and you basically get that, hey? 3x is 25 plus 5.
Yes, yes.
And then you get 3x is 30. And what did you do next?
I divided it by 3.
Okay, where did you divide by 3?
I first divided 3x by 3, which canceled it out and gave me x.
What do you have to do? What do you have to do if you do it to the one side?
You have to do it to the other side also.
Okay, and then you tell me about the cancelling, yeah?
3x divided by 3 gave me x.
Yep.
So I did that, and then 30 divided by 3 gave me 10.
Perfect.
So x is equal to 10.
Well done.
Well done, Scarlett. That's brilliant. Well done.
Okay. So what I want to do is I want to take a quick break. And so I want everyone to stand up and show me their favorite stretch. And this is an important part of the lesson, just as important as the equations. So I would love to see my students stretching out, doing their favorite stretch. I'm going to do a calf stretch. Sichaba, let's see you off your seat, standing. Nwazi, let's get you standing up. Lenovo, I want to see you stretching. And just give yourself a break. Let's do it. Let's stretch it out. Your brain will thank you. Trust me, I've been doing this long time. Even though you don't want to do anything right now, it will help you if you do stretch.
Yeah, it will definitely help. What's the Chaba? I'm watching you.
Let's see those. Let's do
this. Wazi, I only see your hand. Let's do it.
I want to see you stretch.
With the things that shall not be named.
And then once you've had a good stretch, come on, you can. I believe in you. Don't be afraid to stretch, guys.
Yes, guys, it's very important. Woo, Golinova, I see you. Mehdi, I see you. Hey, Charlotte.
Okay,
so,
let's do our brain break after the stretch. Guys, we've got some angry birds or angry cows or something. I don't know. But can you solve the brain break? Okay. And it looks like a duck or something. 3 ducks give you 30. Is it duck or I don't know what it is. But we want to know, what animals are these?
Funny things.
A cow and maybe it's like a brown cow times some sort of bird. Oh, I don't even know. I don't know my animals, guys. You're gonna have to help me out. Okay, so the first one we've all agreed. I can see in the chat it's 10. Okay, no problems there. What do you think this is? It a brown cow? What do you think this thing in brown is? A donkey. I like that. Let's call it a donkey.
Yeah, isn't that a pig?
Or if it's a piggy, who knows?
I have no clue.
the donkey or the piggy is going to be 5 based on what I'm hearing from students. Now we have to be we have to be careful because the cow, there's lots of them here. And so that's going to affect our final answer. So how much is each cow worth? So each of them together is 2, but I think each of those is 1. And if each of those is 1, that means this must be 1. So what is the final answer? So what is, I think it says 5 minus 10 minus 1. Pop it in the chat, guys. Pop it in the chats. Okay, so for me, BODMAS says I must multiply before I subtract. So it gets 50 minus 1, which then gives me a final answer of 49. And I see lots of students have got to that. So
well done, guys. Well done.
Now, guys, because you've been smashing it so much on equations, we're actually going to keep going. But just to let you know, there is a Maths 24 question here that if we have time, we'll come back to. And this is for now. We're going to keep the Maths 24 in that part of the lesson. But for today, we're just going to keep jumping ahead here with our equations. Now, what I want to do is I want us to try and solve the next 3. But they're a little bit harder. And there is one, 10.6, where I'm going to have to get you all to help me with. But it's not impossible. Some of you will be able to see where to go. But we're definitely doing 10.4 and 10.5. And for those who are feeling like you can just keep missioning, we'll do 10.6. Okay, over to you guys. Let's do this.
Let's go, guys. Remember, we put those marks in the bag. So start with 10.4 and let's move.
10.4, go from there.
Let's do this, guys.
You can do it. I agree, Charlotte. I agree, Sivanati. I think you're on the right track there.
Marks on the bags.
Okay, so the first one is 8. That's a little.
Don't mark it, guys.
But 10.5 and 10.6 are a little bit tougher, so you're going to have to work a little bit harder for those ones.
I saw my people already giving me 10.5. That's how
is it?
They are. Yeah.
10.6 is a bit tougher, but I think you can follow the breadcrumbs there. I think we're.
You guys are awesome. I see 10.5. We have a lot of answers there. So let's see. We're going to mark it just now.
Yeah, I think the plus 24 is giving me the biggest headache right now. If only I knew how to get rid of my headache. Who can tell me how to get rid of my plus 24 headache?
Come on, who's taking the 2 marks inside? Someone's hands, they raised their hand.
Let's go to Sibo. Sibo, how do I get rid of my headache? Yeah.
Sir?
Yeah.
I don't understand 10.4.
10.4? So 10.4 is just to say can you see there's my headache in 10.4 is plus 4. So I've got 4 plus x. And so the opposite operation of, what's the opposite of adding 4, do you think? If I said to you, you add 4, what is the opposite of adding 4?
What's the opposite?
Would be subtracting 4, huh? No. So if you add 4, the opposite of adding 4 is to subtract 4.
Mm-hmm.
So what I did with 10.4 is I said, you've got 4 plus x equals 12. I'm going to take away 4 from both sides. And when I take away 4, because it's the opposite, so when I go 4 minus 4, I get nothing. It knocks out the original 4. And all I'm left with is x equals 12 minus 4. And what's 12 minus 4? It's going to be 8. Does that make sense? Okay. So, let me just quickly, with this one, to get rid of my headache, it's a similar idea. I'm going to take away 24 from both sides. And why am I taking away the 24? Well, because it knocks out the plus 24 and I get 2x. Oh, sorry, guys. I just had a transition to nighttime on my computer. And so what I'm then going to get is I'm going to go, what's 44 minus 24? And it's 20. Who would like to help me finish off that question? So I'm going to go to Neo. Neo, can you help me? Or how do I go from that next step?
Hello, Neo.
Sir.
Yes.
What question should I actually be doing right now?
So I want to, can you help me? I'm stuck at 2x equals 20. I want to know what the next step is from that point onwards.
The answer for 2x equals 20 is 10.
Okay, but tell me the steps. Charlotte, I see you. What do I have to do? Neo, sorry, what are the steps I have to do? Okay, so I see Charlotte said it in the chat, that's why I was saying it, but Neo, you divide both sides by 2. If you divide both sides by 2, these 2's cancel out and you get x is equal to 20 divided by 2, which is 10. And so x will be equal to 10. Okay, let's have a look at 10.6. I would love someone to tell me about what the first step is in 10.6. I'm going to go to Malusi. Maybe Malusi can help me. Malusi, what do you think the first step to solve the equation 10.6 is going to be?
Sir.
Yeah.
My question was on 10.5.
Okay, it's fine. Ask a question. What do you?
Sir. I was basically confused on how we actually had to do the sum as a whole.
But did the explanation help you a little bit?
Kinda, sir, but I don't know how we got to the minus 24.
Okay, let's just have a quick look. You're not the only one here. When we start this question, do you agree that 2x is the term that has a variable in it? 2x?
Yes, sir.
Okay, now what is closest to the 2x?
The positive, the plus.
Yeah, the positive 24. So basically, if you think about what I did, I just rewrote the equation in black. And then I said, I'm going to do the same thing to both sides. What did I do to both sides? It's written in blue. What did I do?
You took away 24 from each.
Okay. Now, why did I take away 24 and not 25?
Sir, because you can't take away 25 from 24.
Yes. If I didn't take away 24, it wouldn't knock it out. So I'm getting rid of it. I'm using lots of analogies, but I chose to take away 24 because it's the only number that will get rid of the plus 24.
Yes, sir.
And so now all I'm left with is 2x on the left-hand side. Now on the right-hand side, I can't just do one thing and not do the same thing to the other side. So that's why you see a minus 24 on the other side. And
Yes,
so
sir.
what you see is 44 minus 24 is 20.
Yes, sir.
Okay, but now can you see why I divided by 2 in the next step? Where was that coming from?
So wouldn't the 2 be coming from like the 2 in like the actual sum, like from 2x?
Yeah. So the opposite of timesing by 2 is dividing by 2. And so the
Yes.
dividing by 2 is trying to get rid of this the 2x part so that I left with just an x by itself.
Oh, so sir, both 2 and 20 would be like divided by 2 in order to get 10x.
Yes. Yeah. So I'm doing the same thing to both sides. I'm just doing a different thing this time because the problem is different.
Okay. Yes, sir. And then, sir, with 10.6,
Yeah.
wouldn't it be like whatever's outside of the bracket gets times with what's in the bracket? So it'll be 3x negative
Yeah.
4, minus 4.
Not minus 4. So the 3 must get applied. You're almost there. So,
So, do you apply to both of them? So it'd be 3x 12.
Okay, minus 12.
Yes. And then equals 2x plus 7. And then
okay, let's stop for a second. You've done very well. I just want to, because I need to actually explain this, but thank you so much, Melusi. You were fantastic.
Well done, Melusi. Well done.
Okay, so guys, what I want to do is we'll carry on with this in the next lesson. But what I want to point out is that this is a different type of question. We now, for the first time, have a situation where we have variables on both sides of the equal sign. Now, we know how to get rid of, if I say to you, let's do this together actually. How do I get rid of minus 12? Based on everything I've done today, like if I want to get rid of minus 12, but still not break the equation, put it in the chat. What do I need to do? Okay, I add 12. I can clearly see that that is happening in the chat. Now, the good news is when equations get more complicated, we do a little bit less working out. So if I add 12 to both sides on the left, or if I add 12 to the left-hand side, give me a thumbs up if you see how I get 3x. So I'm living in this box and I'm adding 12 and I'm saying it's 3x. Give me a thumbs up if you understand how I get 3x. Okay. Now the problem is, guys, I've broken my only rule, which says I must do it to both sides. Now I've only done it to one side. I want to know if I add 12 to the right-hand side, what am I going to end up with? Okay, add 12 to both sides. What do I end up with on the right-hand side? Okay, guys, let's keep the chat focused on the maths. So if I add 12 to the right-hand side, I've still got my 2x, but then 7 plus 12 is going to give me 19. Okay. So guys, what I'm going to do is I'm going to pause the lesson at that point because we've made really good progress today. You still, in the next lesson, I'm going to carry on with the equations. And I'm going to keep coming back to this idea. What is the opposite operation? And have you done it to both sides? That is where we're going to just keep practicing, but we will get to slightly harder equations like these ones over here. So I will see you all on Monday next week. And then, Yolanda, if you could pop the link to the quiz in the chat. And yeah, I just want to say, guys, if you're still feeling a bit unsure with equations, Luyanda, we're not doing polls today because we are going to do them on Mondays. So Mondays is poll day, Wednesdays is quiz day. Okay. All right.
Well done, guys.
Thank
you, sir.
Pleasure. I know it's slow going initially, but you just keep practicing and you'll get this.